So today we will be solving Summer 16, paper 31, question number 7. So the question says, the equation of the curve is this. Show that dy over dx is this. So basically we need to find the derivative first. So here this is our curve equation and this is the derivative which we need to prove. So we know that the derivative of x cubed is 3x squared. Now we need to find the derivative of 3x squared y. So to find this, we are going to use the product rule. I've written it right here. So you can check this out. It's given in the formula sheet right here. So under this differentiation, it's given. This is the product rule. So you don't need to memorize this. Now, here the thing is 3x squared y. So u is 3x squared and v will be y. Now, the derivative of 3x squared is 6x and the derivative of y is dy over dx. This is v dash. So, using the formula, it will become 6xy plus 3x squared dy over dx. If there is a minus sign, you should keep this in mind and write whatever you got as the derivative in brackets. Otherwise, your values can change due to the minus sign. 3xy plus, sorry, it was 6xy plus 3x squared dy over dx. Now, lastly, we have y cubed. So the derivative of y cubed is 3y squared. And I'm going to erase this to get some space. Dy over dx. And the derivative of any number, here it's 3 is 0, so it'll be equals to 0. Now I'm going to simplify it further, like we're going to expand the brackets, so it will be 3, let's just change color, so it will be 3x squared minus 6xy, so we're multiplying this minus 3x squared dy over dx plus 3y squared dy by dx is equals to 0. Now what we can do is we can bring all the dy over dx on one side and the rest of the values on one side. So I'm going to shift these on the other side. So it will become 3x squared minus 6xy is equals to 3x squared dy over dx minus 3y squared dy over dx. Now we can divide this whole equation by 3 as it's divisible by 3. Divide by 3, so we get x squared 2xy is equals to x squared dy over dx minus y squared dy over dx. Now we can take the dy over dx as common. So it will be x squared minus y squared, and here we have x squared minus 2xy. So to find, now we'll just make the dy over dx as subject, so this will be divided. So it will become x squared minus 2xy divided by x squared minus y squared is equals to dy over dx. And we can tally if this is same. X squared minus 2xy over x squared minus y. Yes, it's same. So this is the first part. Now moving on to the second part. We'll do it in red. Second part. Okay, so in the second part it says find the coordinates of the points on the curve where the tangent is parallel to the x-axis. So whenever they talk about the tangent being parallel to the x-axis, we tangent parallel to x-axis. So whenever this is given in the question, we just equate the numerator numerator of dy over dx to 0. So here the numerator of dy over dx, as you can see, is this. This is the numerator. So numerator is x squared minus 2xy is equals to 0. So we equated it to 0. Now I can bring this on this side. It will be 2xy. X can get cancelled. So x is equals to 2y. Now I can substitute this x in the curve equation. So substitute x in curve equation. So curve equation was, let's just check it. It was x cubed minus 3xy 3x square y plus y cube is equal to 3, I think. Yeah. So now we'll substitute. It will be 2y cube minus 2y square y plus y cube is equals to 3. So this will become 8y cube, and 3 into 4 is 12. So it will be 12y cube plus y cube is equals to 3. This is 3. Yeah. Now 8 minus 12 plus 1. 8 minus 12, it will be minus 3 y cube is equals to 3. So 3 and 3 will get cancelled out. So minus 3 cube is equals to 1. So y cube is equals to minus 1. Now we have to make y the subject. So we will take square cube root. So cube root of minus 1 is minus 1. So y is equals to minus 1. Now we will substitute this minus 1 in the x value. So our x value was this. This is our x value. X is equals to 2y. I'll write it here. X is equals to 2y. So we know that y is equals to minus 1. So x is equals to minus 2. So one of the coordinates is this, minus 2 and minus 1. But here in the question it says find the coordinates of the points on the curve. So points means that there are more than one point. So we need to find the second point. This is the first point. Alright, it's the first point. Now we need to find the second point. So to find the second point, what we have to do is we have to substitute y is equals to minus 1 into dy over dx. So our dy over dx is x square minus 2xy x square minus y square. So we will substitute minus y. So it will be x square minus 2x minus 1 over x square minus. So this will become x square plus 2x and x square minus 1. Yeah. And our dy over dx is equal to 0. So sorry about this. Now let's just change it. So x square plus 2x over x square minus 1 is equal to 0. So if we solve this, we'll get x square plus 2x is equal to 0. You can put this into calculator and solve it, or you can solve it using the quadratic formula. You'll get x is equals to 0 and x is equals to minus 2. So we have already solved for x is equals to minus 2, as here x is equals to minus 2. So we have solved for this, so we'll take x is equals to 0. So our x is 0. Now we will substitute x is equals to 0 in curve equation. So our curve equation was x cube minus 3x square y plus y cube is equals to 3. Let's just check if it's correct. X cube minus 3x square y, yeah, it's correct. So now we just have to substitute. So 0 minus anything multiplied to 0 is 0 plus y cube is equals to 3. So y will be, it will be cube root, and we'll get y to be 1.44. So this is our second point, 1.44.